I'm starting this video with a new project called Scanner Project. Before I start, I'll paste the same file from the previous video, which had some off-quoted text in it here. In the main method, I'll create a new variable type scanner named scanner followed by equals new. Pausing here, what I want you to see is the number of options available for constructing a scanner. You can pass many different types of sources to this constructor. There's file, path, a string which I've covered previously, a readable, an input stream, and something called readable byte channel. In addition, there are overloaded versions that let you pass a character set or a character set name. I haven't really talked about character sets a whole lot, however I'll cover them in the next video. Let me finish setting up this first scanner variable using a new file instance and passing that the name of file.txt as a string literal. Not unexpectedly, I get a compiler error because of the possibility of a checked exception. Before I deal with that, I'll first surround this declaration in a try with resources block. A scanner isn't automatically closed, so if I didn't put that in a try with resources block, this code would keep the file open. I didn't have to worry about closing a scanner when the source was a string, because a string doesn't open and hold onto an open resource. We've used scanner before with system.in. As it turns out, system.in is a special input stream called the standard input stream. It's a special case because the JVM opens one instance of it for console or keyboard input and you don't want to close it. If you close it, it cannot be reopened and any attempts to use it will result in an exception during your program's execution. You've had lots of practice with this type of input stream. Working with other kinds of input streams won't be too different. Next, I'll add the catch clause so this code will compile. The great thing about using Scanner is that once you're familiar with its functionality, you can easily process data from various input sources in a consistent and standardized manner. Next, I'll demonstrate how to use a while loop in combination with the hasNextLine method to check if there is more data available to process. NextLine is doing just that, getting the next line in the file. Running this now. You can see the text file printed out line for line. This isn't quite as easy as using buffered readers.lines method, but it's still not very complicated code. You might remember, in a previous video, I used the tokens method to get a stream of strings. Let's look at that again. Let me comment out this while loop. I'll use tokens next to read the file, but first, let's review what delimiter the tokens method will use. I can do this by printing out the result of invoking the delimiter method on scanner. Let's see what comes back. You'll see a regular expression. Hopefully you know what this means. The text will be split by one or more white space, any white space, which includes new line characters. What this means is if I use tokens with the default delimiter, I'll just get a list of words. That's not what I want, so I'll set the scanner's delimiter. I'll use a regular expression and just put a $sign there, which is a meta character for end of line. Here, I'll call tokens, which returns a stream of string, and print each string I get back. Let's review the output. I get the same result as the while loop example. Each line of text in the file is returned on the stream, and I can work with lines of text rather than words. Another method that I don't think I covered in the regular expressions section is the findAll method. I'm going to comment out the three statements in this try block. Next, I'll call scanner.findAll, and I'm going to pass that a string, but one that contains a regular expression. I'll type this in and I want you to study it for a moment. A mini challenge for you is this. Can you figure out what this regular expression will match on? Before I give you the answer, you should know this returns a stream of match result items. This is very similar to the findLine method I reviewed in the regular expressions section. Because it returns a match result, I'm really interested in what came back as the whole match. Maybe you'll recall that the match result type has group methods on it, and the group method with no arguments returns all the characters that match the regular expression. I'll map the match result to a string using the group method. I'll use a method reference here, so match result, ::group. Next I'll include the distinct intermediate operation, followed by the sorted operation, and print out each stream element. Match result has not been imported automatically for some strange reason. I'll click it to see if I can get an IntelliJ pop-up. No luck with that, so I'll just enter the import manually. This does happen occasionally, with IntelliJ, even with auto imports on. Okay, so were you able to guess what the result would be? I'll run this so we can see. What I get back is a list of words that are 10 characters or more, so the big words, in other words, that are in the full body of the text. I don't have any duplicates, and they're ordered naturally in alphabetical order, in other words. You can see that this method can help you very quickly scan the entire text in the file for matching elements. I'll show you a slightly different take on this. In the resources section of this video, you'll find a file called fixedwidth.txt. I'm going to add this file at my project root. If I open that up, you'll see it has a list of employees with a name, an age, a department, a salary, and the US state they live in. This is a fixed width file, which is a file containing data with no delimiters. These files are usually accompanied with a specification telling you the field names and the start and end index of that field in the line of data. In this case, the first line of the file is telling me the field names. The name is 15 characters, age is 3 characters, department is 12, salary is 8, and state is 2 characters. Getting back to my code, I'll first change the name of my file to fixedwidth.txt. I'm also going to again comment out the statements in this try block in case you want to revisit this code later. I'll create a local variable called namedResults and assign that the result of calling scanner.findAll. In this case, my regular expression is going to group each column. I'll use parentheses to specify each group, and in the parentheses I'll have a dot, meaning any character, then specify the exact width in curly braces so it will match the fixed width length of characters. The first will be 15 in curly braces. Next I'll make it 3 characters to match, then 12, then 8 for the fourth column, and 2 for the last column, which will be state. I'll end with dot asterisk so that the line won't fail if there are extra characters. I'll use a lambda expression in the map operation, and I'll first get the states from the last column, which is group 5. I'll again use distinct and sorted. I'll collect these distinct values into a string array with the toArray terminal operation specifying the kind of array I want. Finally, I'll print the results out in one statement. I will just fix that typo, the extra period I added, and then format the code so it's easier to read. If I run this now, notice that the output shows ST in my list of distinct states, and that's because of the header row. I can use the skip operation in my stream pipeline to skip the header, so just skipping the first stream element. Running that again now, we should see that removed from the output. I get the distinct list of states, minus the header. Now the code has skipped it. I can now do this with any field, so let me try it for a department, the third column. I will run that again. Notice this data contains the extra spaces because each value is fixed at 12 characters, and this includes any white space. I can fix that by tacking on the trim method in my map operation, running it again. My department listing is now trimmed of extra white space. The combination of regular expressions and streams has made it very easy to do analysis on file data you receive. There's a lot of methods on Scanner which let you read different data types from the input, but these are more geared to reading object stream data, which I'll cover later in this section. What I want to focus on right now is this overloaded constructor on Scanner. Going up to the declaration of my Scanner, I'll Control-click on Scanner. This brings up the Scanner constructor code that takes a file as the source. By now you know the file class is IO and not NIO2, but let's examine this code a little bit. You can see it's calling another overloaded constructor and passing what looks like a readable byte channel. This is definitely using NIO2 functionality. I haven't covered channels yet, and I will in this section, but it's interesting to know that even though we think we might be using an IO class, like files and Scanner, the underlying functionality is taking advantage of the NIO2 enhancements. Let's get back to the main method, and instead of a file, I'll now construct this Scanner with a path variable. Instead of a file not found exception, I'll need a catch clause for IO exception. I'll click on Scanner, and that should give me the light bulb gutter icon, and that will show me several options. I'll select the replace file not found exception with more generic IO exception option. If I run this code, I get the same results. I'll do the same thing I did earlier and Control-click on the scanner keyword in the try block to have a look at the constructor code. Somewhat surprisingly, this is a bit different than what we saw previously. Here, our path is an argument to a method on the files class I haven't really covered, new input stream. Let's follow this trail and see where it leads. I'll Control-click on that method name, new input stream. That's delegating to something called a provider, and it's new input stream method, so I'll Control-click on that. Now if I look past that first if statement, I'll see that here again is the readable byte channel. This means that again this code is taking advantage of the NIO2 enhancements to file input. Let's try yet another constructor in our main method. This time I'll pass a new file reader. This code compiles with that one change. I'll confirm it works as before, and my results are the same. Once more I'll see what the constructor code will reveal. This is calling an overloaded constructor, so I'll Control-click on the this keyword. What's notable here is there isn't any transformation of the source to another type of input stream. When you construct your scanner with a file reader, the scanner will use the I/O file reader, meaning it will have minimal buffering and so on. I'll go back to the main method one last time and wrap that file reader in a buffered reader constructor. This code compiles and runs with the same results. Once more I'll examine the constructor. You can see this looks like the same constructor the file reader used. I'll Control-click on this and confirm it. There I can see the same code. Okay, so what was the point of this exercise? I wanted you to see that the scanner will take advantage of NIO2 functionality if you use either path or file to construct the scanner. There are times when using that functionality may not be a good fit, and I'll discuss that when I get to channels later in the section. For those times, you can still use a file reader or preferably the buffered file reader and use the underlying legacy I/O sources. Okay, this video is getting long. In the next video, I'll be discussing the different ways to read a file with the NIO2 classes, but I'll start with a review of character sets. I will see you in that next video.